The safety of the pilot and the life of the aeroplane depend on the reliability of the airframe and its engine. Freedom from breakdown can only be obtained by frequent and regular inspection. Efficient maintenance depends not only on the skill and diligence of the airmen, but on the interest and supervision shown by the officers and NCOs. So that the work may be done efficiently and quickly, a maintenance schedule has been prepared for each type of aeroplane. It describes the maintenance routine which is normally required. If anything needs attention that is not covered by the schedule, then it does not mean that the work may be neglected or postponed. This is so important that I shall read the actual Air Ministry instructions. The schedule is not to be interpreted as absolving any persons concerned from the responsibility of acquainting themselves with or acting upon any circumstances indicating the necessity for additional work. The schedule defines what is to be inspected more frequently than others. In this film, the daily inspection only is described. There are other inspections which must be made between flights, after every 30 hours, 60 hours, and 240 hours. For the purpose of reference, the aeroplane is divided into a number of assembly groups, each distinguished by reference letters, such as UC for undercarriage, and PP for power plant. These groups are subdivided, each subdivision being given a number, which denotes a specific operation. An aeroplane maintenance form is provided for each aeroplane. This is kept in the flight office. It is known as Form 700. On the inside covers are directions for use. The daily inspection certificate is printed inside. This certificate shows that the daily inspections have been duly completed. It is initialed by the flight rigger, flight mechanic, instrument repairer, wireless operator, electrician, and armorer. The flight NCO countersigns it, signifying that he is satisfied that all the inspections have been properly carried out. It is also countersigned by the pilot before the aeroplane leaves the ground. The middle page contains the change of serviceability and repair log, a record of all repairs, modifications, and replacements. The periodical inspection certificate refers to the 30-hour, 60-hour, and so on inspections. The aeroplane is taxiing in. You will note that the flight mechanic and flight rigger are going out to meet it. Owing to the pilot's restricted forward view when taxiing, on approaching the aprons round the hangars, these two members of the crew always assist the pilot by placing themselves at each wingtip and guiding him in the direction they want him to go. Refueling is always carried out immediately an aeroplane lands and before it is wheeled into the hangar. One reason for refueling immediately is that condensation in the petrol tanks is prevented. Any water in the petrol system might obviously be the cause of a serious accident. On no account may aeroplanes be refueled inside the hangar because of the danger of fire. The aeroplane's crew take charge and wheel it into the hangar. It is still considered serviceable and will remain so until 24 hours have elapsed since the last daily inspection. A between-flight inspection is carried out after every flight, the details of which are not entered on the maintenance form. The flight mechanic is now seeing how much oil is in the oil tank. The oil level is determined by the position of the filler cap, which is so placed that it automatically provides sufficient airspace above it to allow for oil pumped out of the engine by the scavenge pump and for the expansion and frothing of the oil at high temperatures. And the flight mechanic fills up to the level of the cap. Normally, the undersurfaces of the main plane, the wheel recesses, and the oleo legs are cleaned each day with a clean rag to remove grit or mud which handicap the retraction of the undercarriage. Mud splashed up by the wheels is more difficult to remove after it is dry. Oil is easier to remove while the engine is still warm. Petrol must never be used for cleaning purposes. This film is intended to show how a typical daily inspection is carried out. In some units, it is more convenient to carry out the inspection in the evening. In others, part of the work is done in the evening and the remainder completed the following morning. In this squadron, the daily inspection is carried out in the early morning. Provided that inspection is carried out every 24 hours, latitude is allowed to units as to the time of the day at which the inspection may be carried out. A night bombing squadron will probably adopt a different routine from that of an Army cooperation squadron, in which the conditions are different. In this film, it's been necessary to show the flight mechanic, flight rigger, wireless operator, electrician, instrument repairer, and armourer carrying out their inspections separately. Normally, of course, they would all work at the same time. In an actual inspection, the airmen go round in an anti-clockwise direction, examining, as necessary, each part as it is arrived at. For the sake of clearness, this procedure has not been adopted in the film. Instead, the inspection in each case, such as UC or undercarriage, is completed before another group is started on. The time taken for a daily inspection will vary with the type of aeroplane and engine, but it shouldn't normally take more than 1 hour. Schedules are only issued for guidance, and the CO of a unit may adopt them as they stand, or amend them or modify them to suit peculiar local conditions. The commanding officer takes care to avoid including items for inspection which are not essential to the proper maintenance of the aeroplane, because the inclusion of too many items may lead to attention being diverted from vital inspections to those of little or no importance. We start off with the rigger's inspection. He first of all looks at the change of serviceability and repair log in Form 700 to see that nothing has been put unserviceable. Then he positions himself well in front of the aeroplane so that he can get a rapid general view of it. Thus he gets an immediate impression of the trim. A tire down, low pressure in one of the oleo legs, or other faults will be noticed at once. Now he is going in to start on the first group, the undercarriage. He inspects this for damage and then gets under the wing to look up at the retracting gear, which also he assures himself is undamaged. There is often a good deal of mud, especially on wet days, owing to the wheels being drawn up into the recesses, leaving some of the mud they've picked up behind when they're lowered again on landing. So the rigger gets busy with a rag and carefully cleans the joints, pivots and fairings, and re-greases as necessary. The undercarriage, when raised or lowered, is locked into place by means of pins controlled by cables, and it is the rigger's next job to see that these cables are not slack. The oleo leg comes next. The pressures should be normal. He can check whether this is so or not by noting the sliding portion of this is exposed for not less than 3 1/4 inches. If there has been excessive oil leakage, the sliding portion would show signs of this in the form of streaks of oil, and of course the leg would be low. The sliding portion is kept greased, and grease may pick up grit, so the next thing he does is to clean the old grease away and apply fresh. He then lubricates the glands through the nipples, 2 turns of the grease gun handle per nipple. He now turns his attention to the tires and tests them for pressure, using a pressure gauge. Now the outside of the tires for damage. This is a very important part of the inspection, as at the high speed at which the Spitfire lands, a weak tire may be the cause of a serious accident. That finishes the rigger's undercarriage inspection. The next part of the aeroplane to be done is the cockpit. He is examining the gauge which registers the pressure in the air containers. This must be at least 270 pounds per square inch. If it drops below 250 pounds, the guns won't fire effectively. Now he is trying the brake lever. The action of the rudder bar not only moves the rudder, but actuates the wheel brakes for control when taxiing. Thus, a turn to starboard applies the brake on the right-hand wheel, and a turn to port, the brake on the left-hand wheel. He is testing the rudder movement and seeing that it gives sufficient pressure in either brake. The pointers on the air pressure gauge refer to the brakes on the wheels. Port, starboard. When both brakes are on, the pressure of each should be equal, as you see here. He leaves the parking brake on. Thus he keeps the aeroplane still for the rest of the inspection. He will check the pressure gauge when he has finished his inspection to see that the air pressure has been properly maintained in the system. That is to say, if the gauge drops back, it will show him there's a leak somewhere, calling for further investigation. Now he operates the control column and makes sure that the elevator has a full and free movement, and the same with the ailerons. Then he operates the rudder bar and sees that it gives free and full movement of the rudder. Note these tabs on the elevator and rudder. They are the trimming tabs. Their position is controlled by these 2 wheels. This one controls the elevator tab, which gives the aeroplane nose trim. In order that the rigger can watch its movement from the cockpit, he lifts the elevator, which brings the tab into his view. He now operates the control and sees that it has full and free movement. Likewise, the rudder trimming tab. He operates the rudder bar until he can see the tab clearly, and then tests out the control for full and free movement, in both cases seeing that the play is not excessive. He now checks up the nose trim indicator and sees that it agrees with the position of the elevator tab control. He operates the landing flaps. The undercarriage is normally lowered by the operation of a hydraulic system. But should this, for any reason, be out of action, there is an emergency system controlled by this lever, which is sealed up. The rigger must see that the wire sealing the emergency system is intact, for if it had been used, it means that the hydraulic system has failed and will have to be dismantled, cleaned, inspected, and refilled. While still in the cockpit, he inspects the safety harness attachments for security. He pulls the harness shoulder straps and sees that the release gear works properly. He next examines the hood and windscreen and sees that they are clean and free from cracks. Then he seats himself in the cockpit and draws the hood over to see that it moves freely. He is now seeing that the latch in the closed position holds and can be released. Sliding the hood open again, he tests the latch in the open position in the same way. That finishes his inspection so far as the cockpit is concerned, and he now turns his attention to the fuselage, which he inspects for dents and cracks, particularly on the underside. This brings him to the tail unit, and he examines the surfaces of the fin and tail plane for damage. Then the fabric coverings of the rudder, elevators, and trimming tabs for damage and loose stringing. The rudder and the elevator hinges must be kept lubricated, and he gives one turn of the grease gun handle for each nipple. He ends his inspection of the tail unit group at the tail wheel. He inspects the caster unit and sees that the main spindle is not broken. He sees that the tail wheel tire pressure is normal and examines the tire for cuts and damage. Finally, lubricating the hub bearings with antifreeze grease. 2 turns of the grease gun handle. Now he goes to the main plane and inspects its skin for dents, cracks, or loose rivets, which will be detected by cracks in the paint. Then he cleans out the wheel recesses, which are apt to get mud in them from the retracted wheels. He examines the wing flaps for damage and distortion. Then the aileron fabric coverings for damage. The rigger has nearly finished now. He sees that all cowling, panels, and inspection doors are securely fastened, and gives a final look round to see that he hasn't left any rags about. You remember that at the beginning of his inspection he left the parking brake on so that he could check the system for leakage. Now he has another look at the pressure gauge and finds the system in order. The rigger has now completed his part of the daily inspection. All that remains to do is to complete and sign the maintenance form. Now we shall watch the flight mechanic doing his part of the inspection. And we pick him up while he is doing his first job, the air screw group. He, like the rigger, will have referred to the change of serviceability and repair log before starting his inspection, as do the other tradesmen. When the air screws are operated over loose aerodrome surfaces, or in wind or hail, the edges of the blades may become pitted or ragged. This encourages the development of fatigue cracks, and failure may result. It is therefore important that the NCO's attention should be directed to any deep pits or ragging of the blade edges. He tests each blade to see that there is no shake in the hub and no excessive backlash. The spinner must be secure and free from cracks. He checks this and then looks at the rear of the air screw to see that there is no sign of an oil leak. So much for the air screw. The power plant follows. The cowling is removed so that he can get at the coolant pump and header tank, which are next on the list for inspection. He examines the coolant pump for leakage at the gland and gives the greaser not more than half a turn. Should there be any leakage at the gland, he makes any adjustment necessary. The gland nut must be turned by hand only, and this must be done when the engine is warm. Checking the level of the coolant in the header tank, however, must be done when the engine is cold. Ethylene glycol is the coolant used. The system should be filled to the level of the filler cap, which is so placed that it automatically provides sufficient airspace above it to allow for expansion. A valve is incorporated in the header tank to ensure that excess pressure is released from the system. He replaces the engine cowlings and examines them and their fastenings for damage and security. He then gets into the cockpit. He has satisfied himself that the tanks are full, and he operates the switches of the fuel contents gauge for each tank to see that they register correctly. While in the cockpit, he checks the radiator fairing flap control. So far as the fuselage is concerned, the point for examination is the fuel tank, to see that the filler caps are properly secure and that the vent system is clear. He examines the radiator fairings under the starboard plane and sees that it is secure and undamaged. And with the assistance of the rigger in the cockpit, he sees that the flap operates correctly. He inspects the oil cooler to see that it is not fouled or leaking. Then the air intake, putting his arm right up to the gauze in case it might be fouled by grass cuttings or other substances drawn in. That finishes his inspection so far as he can go inside the hangar. He will want to do one or two more things when the engine is run up outside, but we'll refer to that later. In the meantime, we see him looking round to ensure that no tools or rags are left lying on the engine. And then we leave him to complete and sign the maintenance form. The armourer starts his inspection by seeing that the firing button on the control column is in the safe position. He should then ascertain that the guns are unloaded and the ammunition containers empty or removed. Here he is unloading one of the guns by removing a round from its breech. As the containers are not empty, he removes them before continuing his inspection. Then he checks the operation of the firing button for the Browning guns and ensures that fire and safe and rear sear release units are operating correctly. He sees that the sliding sunscreen for the gun sight is clean and operates easily, and that the catch operates efficiently. He sees that the GM2 or GM3 reflector sight is illuminating correctly, and that the dimmer switch is operating efficiently, and checks for deterioration of the graticule. He sees that the firing button is left in the safe position. If the guns have not been fired, he inspects them for security, pulls back the breech block, and pulls through the barrel with the cleaning rod and 4x2. If the guns had been fired, he would remove the recoiling portions and clean them with a dry rag, denickel the barrels and gauge them, then oil and reassemble. He examines the blast tubes for security and the fairings on the leading edge. Lastly, he ensures that the magazine doors and gun panels register correctly and are properly secured. Then the armourer, in his turn, completes and signs the maintenance form. The routine of the daily inspection of the wireless operator starts in the cockpit. He begins by making sure that the remote controls of the RT equipment work freely and are secure. When the tests of the RT instruments are completed, he locks the send-receive switch at off. Well, that's the cockpit group done. Now the fuselage. He opens the panel housing the RT crate, which he examines together with its contents for security of mounting. He makes sure that the wiring doesn't foul the aeroplane control cables. He sees that the 3-point plug for the mic-tel circuit is inserted in the correct socket. If the aeroplane has flown, he changes the 2-volt accumulator for a fully charged one. He examines the airframe structure in the vicinity of the accumulator for signs of spilt acid. Next, he examines the connections for cleanliness and security. A dirty connection would impair the efficiency of the set very considerably. Continuing in the fuselage group, he examines the aerial for security. He pays particular attention to the security of the mast and to the cleanliness of the insulation panel. Dirt and foreign matter on this are going to reduce its insulating properties. He sees that there is no fraying of the aerial wire. He inspects the insulation and lower attachments of the aerial mast for security. And then goes to the tail unit and sees that the aerial insulator and attachments are secure. Now a practical test of the system and a two-way ground test of the RT equipment. That finishes the wireless operator's inspection, and he makes his entries in the aeroplane maintenance form and signs it. The daily inspection of the electrician is an important one. His responsibility is on the increase with modern aeroplane equipment. He starts by examining the engine-driven generator, the mounting, drive, and the air cooling pipes for security. He then inspects the cable connections to the engine-driven generator for cleanliness and security. Now round to the other side of the power plant to examine the electric starter motor, the magnetic relay switch, and the remote battery socket for security. Then the cable connections to these, to the electric starter motor, the magnetic relay switch, for cleanliness and security. In the cockpit, he sees that the visual and audible undercarriage warning indicators and their connections are secure. He operates the undercarriage main indicator switch to the on position by means of the throttle lever and sees the indicator board lights correctly. There are 2 lamps behind each window. Should any lamp be defective, he would replace it. He tests the working of the blind for night use. He sees that the indicator and connections are secure. He tests the working of the audible warning by manipulating the switch in the undercarriage. He then examines and checks the ammeter for correct zero reading and security. Next, he sets the generator switch to the on position. Now he tests the identification and recognition lamps by operating them in Morse and steady positions. Next, he ensures that the lamp in the gun sight dimmer screen is operating correctly. The landing lights are retracted by a pneumatic system. He checks their operation and also the operation of the mechanical focusing control. He ensures that full and free movement are obtainable, thus satisfying himself that they are not being fouled by any cause. He inspects the switch in the pressure head heater circuit for cleanliness and freedom from moisture. There should always be a smear of grease in the slot in which the tumbler operates. He is now making sure of this. He switches on the pitot head heater for a period of not more than 5 minutes. The pitot head must be kept clear of frost, which is likely to affect it at high altitudes. Otherwise, the airspeed indicator, which it controls, would not read true. The electrician gets out of the cockpit and tries the head, obviously warm, showing that the heater element is serviceable. All tests in the cockpit group having been completed satisfactorily, he sees that the electric switches are in the off position. The fuselage is his next group. He examines the 12-volt accumulator for security and sees that the securing bolts have the nuts locked. If an accumulator is not installed, the leads should be connected to the dummy terminal block, this. Now he is examining the accumulator itself and its stowage. He examines the adjacent airframe structure for signs of acid leakage and finds all in order. If he found any signs of corrosion, he would report them to the flight NCO. He then tests the voltage of the 12-volt accumulator under load. Should he find any cell reading less than 2.1 volts, he would remove the accumulator for recharging. He checks the fuel gauges on all tanks to see that the electrical system is functioning correctly. He is now going round to ensure that all lamps and electrical equipment are securely fixed to the aeroplane. he has to get underneath to view the downward recognition lamp. He tests the navigation lights by operating the switch. Now the landing lights. Now the cockpit lighting. Now he is putting all switches at on in order to test the insulation between the poles and earth. After that test has been completed, the electrician's inspection is finished, and he proceeds to make his entries in the aeroplane maintenance form and sign it. We shall next watch the instrument repairer's inspection. Seated in the cockpit, he checks the 0 setting of the rate of climb indicator. Now he sets the subsidiary pressure scale of the altimeter so that it reads the height of the aerodrome above sea level. He tests the blind flying panel for security and the anti-vibration devices for signs of broken springs. He sees that the bayonet unions of the oxygen supply system are undamaged. Next, he checks the contents of the oxygen cylinder. This must be at least 7/8. Should the gauge show less than 7/8, the cylinder must be taken out and a new one put in its place. The instrument repairer's inspection is ended by winding the clock and setting it to the correct time. After which, he makes the necessary entries in the aeroplane's maintenance form and signs it. The aeroplane is taken outside the hangar and positioned into wind for running up. A suitable spot is selected for this as being free from any loose rubble on the aerodrome's surface. Before running up, chocks are placed in front of the wheels. To start the engine, an electrical starter trolley is used. This consists of large capacity accumulators which are plugged into the aeroplane for starting purposes, thus saving the aeroplane's own battery. The flight mechanic takes this opportunity to observe the exhaust gases for signs of coolant leak. He also tests the movement of the air screw from fine to coarse pitch. While the engine is running up, he has an opportunity to test the oil pressure, boost gauge, oil temperature, radiator temperature, fuel, RPM, drop-in revs in port and starboard magnetos, and the voltmeter. The pilot takes his seat in the cockpit, and the fitter does up his safety harness, which must always be secured before flying. The pilot taxis into position to take off with the flight mechanic and flight rigger at each wingtip. When he is satisfied that he is clear and ready to take off, he waves them away. Of necessity, the routine of the daily inspection should and must come to be an almost mechanical performance. But those who are responsible for carrying it out should bring to the work minds that are alert and capable of noticing the smallest defect which may have occurred. The efficiency of the Royal Air Force is second to none. It is your duty to see that as far as lies in your power, this efficiency remains unimpaired.